Here we go. Determine how many different codes can be formed if letters and digits may be repeated. What's our scenario? A company generates a 4-character code using the 26 letters of the alphabet and the 10 digits 0 to 10. And the code is in the form letter, digit, letter, digit. And then 12.1, we are supposed to find the total number, right? The question says determine how many different codes can be formed if letters and digits may be repeated. So we have letter, digit, letter, digit. So how many letters do we have? We have 26, right? And then how many digits do we have? We have 10. But repetition is allowed, right? How many different codes can be formed if letters and digits may be repeated? So when we fill the third spot with a letter, we still have 26 options. And when we fill the fourth spot with the digit, we still have 10 options. So the answer here, so that is 26 squared multiplied by 10 squared. 67,600. So there we go. That is the answer to 12.1. Let's take a look at 12.2. Looks like we have some conditions here. Determine how many different codes can be formed if the letters D, F, I, Q, U, and V may not be used. So of the 26 letters, how many are we subtracting? 1, 2, 3, 4, 5, 6. So we are subtracting 6 letters. And now we only have 20 letters, right? Okay. And then the code may not start with a W or Z. Is W or Z one of the letters that we eliminated? No. Okay. That is important to address. Letters or digits may not be repeated. Okay. And then the code ends with an odd digit. Okay. So those are our conditions. Let's go ahead and play around and see what we can come up with. Okay, so we have one. What am I doing? We have 1, 2, 3, 4 spots that we need to fill. So let's start with the spots that have conditions. The spot that have conditions is the first and the last, right? We have special conditions there. So the last spot, the code ends with an odd digit. So how many odd digits do we have? So the digits that we have is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So odd, that is even. Odd, 7 is odd, 9 is odd. So we have 1, 2, 3, 4, 5. We have a possible of 5 digits that can fill the last spot. We have only a possible of 5 digits that can fill the last spot. Okay, so we put 5 there because of that. And then let's come to the first spot, which we also have a condition. The code may not start with a W or a Z. So how many letters can possibly occupy the first spot? We have only 18 letters that can possibly occupy the first spot because we have removed 6, right? Because we cannot use them anymore. But of those 20 that are remaining, we have 2 that are not supposed to occupy the first spot. So we have 18 there. And then the second spot, do we have any condition there? No, we just need a digit, right? But we have already exhausted 1 digit on the last spot. We have exhausted 1 odd digit. So of the 10, we are left with 9 here on the second spot. So there goes 9. And then on the third spot, we've already, of the 20 letters, right? We've already used 1 on the first spot. So we're actually left with 19 there on the third spot where we need to assign a letter. So let me put this in my calculator. 18 multiplied by 9 multiplied by 19 multiplied by 5. This is equals to 15,390. So the W or Z, they should not occupy the first spot. Okay, so I'm quite happy with what we've done there. Okay, this is the answer to 12.2. Let's take a look at 12.3. 12.3 is just out of 2 marks. So I want you guys to let me know in the comments. How did you answer this question? Calculate the percentage increase in the number of different cones that can now be formed. Right. So how did you answer this question? What is your solution? Can you write it down in the comments? I'd like to see what your answer is. There we go.